Good afternoon, Varandal. Today we will discuss a topic that is the estimation of elasticities in regression analysis. So previous classes we have discussed about that how we can estimate the parameters and how we can test the whether the particular variable is significant and insignificant. So we have discussed about the t statistics value, how on the basis of t statistics value. So we'll come to know that which variable is the significant influence on the dependent variable. Then we will come to know that how we can estimate the elasticities. And today we will discuss about this one and how what is the interpretation of estimation of elasticities. And today we will discuss also that partial elasticities also. See, as per that earlier class or to the continuous class of previous classes, so we have discussed a little bit of regression. So we will discuss a little bit of regression also today now. So the term of regression was coined by the Francis Galton. Nothing but the term of regression so was coined by the Francis Galton in 19th century. Uh, so why the Francis Galton has coined that regression? So here to describe a biological phenomenon, So what is meant by biological phenomenon? I think Francis Galton is one of the statistician, so who has done a lot of research in the biological innovations and biological phenomenon. So you want to know that whether the is there any relationship between the father's height and son's height. For example, if you take into account, they will take measures of the father's height and their son's height. So which one is the influence and which one is the effect? Nothing but which is the cause and which is the effect. So on the base of his thought only, the regression was kind and it was more popular in our economics as well as commerce and management, number of fields, not only economics, commerce and management. So the regression, the concept of regression, so will be the application of regression analysis will be applicable to the throughout the sciences also, not only social sciences, it can be applied in the sciences also. So what is mean by regression? So regression means the average relationship between the variables. So regression means the average relationship between the variables. And what is the average relationship? Nothing but how much average change in one variable, how much it costs to changes in another variable. That we can come to know that by studying the regression. And another definition also there. So what is the regression? The regression is to study the cause and effect relationship. Regression is to study the cause and effect relationship between the variables. For example, when we studied the correlation in the second semester, so we discussed about that what is correlation and what is regression also there. So what is the correlation? The correlation refers the degree of association. Degree of association. Something but what is the relationship between the two variables? But whereas in regression, so we can come to know the which was the cause and which is the effect, which is a cause and which is a effect variable. Nothing but in regression analysis, we can come to know that cause and effect relationship, between the variables. For example, one variable is a cause, another variable is a effect. So then simple we can write in the mathematical form y is equal to function of x. For example, is a normal equation. So when you convert to the regression analysis in the economics model, then we will write y is equal to beta 0 plus beta 1 x1 plus epsilon or error term. See here, for example, if you take into account, see y is equal to beta 0 plus beta 1 x1 plus e. See here, this is the dependent variable is a independent variable. X1 is an independent variable, x is a dependent variable. So for example, when x changes, automatically there is a changes in y. That is a cause and effect. This is a cause, this is the effect variable. See, in that case, we will come to know that in the regression analysis, which is the cause variable, which is the effect variable, which is the dependent variable, which is the independent variable, and how much relationship between the two variables. How much relationship between the two variables also we can come to know. Then, so as we know that regression, there are types of regression are there on the base of nature of the regression. There are types and there are the number of variables also. There are different types of regression. On the base of nature, we have the linear and non-linear regressions. On the base of variables, there is a simple regression, multiple regression, and partial regression. So simple, we will go with that linear regression. Now we will discuss only linear regression. So what is mean by simple regression or linear regression? Simple, we can say that. So when there is a only one dependent variable, when there is a only one dependent variable and one dependent variable, when there is a only one independent variable and dependent variable in the model is called linear regression. For example, in a particular model, if there is a only one independent variable and one dependent variable is called linear regression. Linear regression, and the coefficient value of x, the explanatory variables are equal to 1. That is called simple linear regression. See here, generally simple regression nothing but when there is a relationship between the one dependent variable, one independent variable is called simple regression. So when it comes to linear regression, so the power value is equal to 1. The power value is equal to 1. And in the linear regression, there is a only one dependent variable, one independent variable. So you can take example, y is equal to beta 0 plus beta 1 x1 plus epsilon. So where y is equal dependent variable is equal beta 0 is constant or intercept plus beta 1 x1. So beta 1 is nothing but a coefficient or slope or parameter. X1 independent variable or explanatory variable plus E is equal to nothing but error term or stochastic term or random term or disturbance term. There are a number of names of error terms. There are around 5 names are there for the random term or error term. So is this clear? What is the regression and who was introduced to the regression and what is the regression and what is the linear regression? Then we'll go with that multiple regression. So the multiple regression, when there is a more than one independent variable. So see, when there is a more than one independent variable and dependent variable in the model. For example, see, in the particular model, if there is a if the independent variables are more than one, it is called multiple linear regression. Simple, we can say the multiple regression also we can call. So multiple regression in the sense when there is a more than one independent variables in a particular model is called multiple regression. So why I told you that a multiple linear regression. So here I put it power value is equal to 1 only. The independent variables power value is equal to 1. There is a beta 1 x1 1 only. Here if I didn't put 1, if it is nothing is there, it comes under the linear regression. If it is x2 square, it comes under the multiple non-linear equation or multiple non-linear regression. So simple, the multiple regression is nothing but when there is a more than one independent variable in a particular model is called multiple regression. So see here, there is a only one dependent variable and there is a two independent variable, nothing but up to n k, nothing but up to n number of independent variable x1, x2, xk, up to xk. There are independent variables, nothing but more than one independent variable. So in a particular equation, see, there is a n number of independent variables. That's why we can call multiple linear regression. If it is only y is equal beta 0 plus beta 1 x1, only one independent variable. So whereas in multiple linear regression, so there is one, two, or more than n number of independent variables. That's why it is called multiple linear regression. So here, whereas y is equal to dependent variable, beta 0 is called constant or intercept, beta 1 is beta 1, beta 2, up to beta k. Nothing but b's. We can write b's are the parameters or coefficients or slopes. X1, x2, up to xk are the independent variables. You can write in the below the equation. Epsilon, error term, random term, disturbance term, stochastic term. Okay. So this is about a multiple linear regression. Then, so before estimation of elasticities, we will come to know the what is mean by elasticity. What is mean by elasticity? Simple way we will come to know that. Then only we will come to know the how we can estimate the elasticities. So before, without knowing elasticity, how we cannot estimate the elasticity. So here we need to understand first thing, that is what is mean by elasticity. So here, see, the elasticity means the degree of responsiveness in dependent variable due to changes in independent variable or independent variables. Simple, the degree of responsiveness in dependent variable due to changes in independent variable. Due to changes in independent variable. So here, if you take into account, this is the equation. For example, in the multiple linear regression, for example, this is a dependent variable. These are the independent variable. So the elasticity means the degree of responsiveness in dependent variable due to changes in independent variables. That is called elasticity. That is called elasticity. For example, here something changes in x1, it will leads to a change in y, or changes in y due to changes in x1. See, when we are taking into account y is equal to beta 0 plus beta 1 x1, only one simple equation. For example, if you take into account, if something is changes in x, it leads to changes in y. It leads to changes in y. That is called elasticity. Elasticity. So in the elasticity, we can measure in terms of percentage. Simple. You can measure in terms of percentage. Nothing but percentage change in dependent variable due to change in percentage change in x variable or independent variables. Independent variables. That is called elasticity. See here, I already mentioned here also. So the elasticity measures the percentage change in dependent variable due to change in independent variables. Independent variables. For example, elasticity you have been learning from that. I think from 12th standards or 11th standard. See, when you study about the elasticity and types of elasticity, price elasticity, income elasticity, cross elasticity. Within the price elasticity, there are 5 types of elasticities are there: perfect, imperfect, unitary elasticity. Okay, relative elasticity, relative inelastic. So when you are learned about these types of elasticities, so how we can test whether the how much the elasticity is there? So simple formula is there to measure the elasticity. That is, the elasticity is equal percentage change in y divided by percentage change in x. Simple, we can say that the ratio of changes in y to changes in x. Think what is the ratio of y to x? Nothing but percentage change in y variable due to change in percentage change in x variable. Simple here, see, or the formula elasticity is equal change in y divided by change in x into, it is not a x1. Simple, you can remember, it is not a x1, it is into here x. So delta y by delta x into y by, sorry, x by y, x by y. This is a basic formula in our theoretical background of elasticities. Okay, is it clear now? Then we will come to know that, for example, how we can estimate elasticity in the simple format. Then only we will come to know that how we can estimate elasticities in the multiple regression analysis or in the regression analysis. See, this is a very important question which we'll ask in the further entrance exams for the MPhil or PhD or NET and SET their exams. For example, see, they will be asked the question, that is QD is nothing but quantity demand is equal 200 minus 2p plus 0.5y plus 0.2 pz, where p is equal 10, y is equal 200, pz is equal 100. Find out the EP, nothing but elasticity of price, comma elasticity of income, and elasticity of price of substitute goods or other goods. For example, if you take into account pz. So what we have to do, for example, here we need to find out elasticity of price. Elasticity of price. So here the formula elasticity of price is equal to quantity change in quantity demand by change in price into P by QD. So earlier I told you that elasticity of price is equal to change in Y by change in X into X by Y and Japan. See here, change in QD nothing but it is a dependent variable is a quantity demand, because the quantity demand is depends on price, income, and other factors. So here Y is nothing but delta Y by delta X. Here X is nothing but P by Y. So that's why I wrote it here, that delta QD by delta P into P by QD. So what is delta QD and what is delta P? Nothing but it means that change in quantity demand due to change in price. Change in quantity demand per unit change in price. You can say that change in common demand due to change in price. So here already they have mentioned that QD is equal to 200 minus 2P. What it tells us simple when you take into account in the general mathematical equation, if it is equal QD is equal to 200 minus 2P. For example, if P value only, you can take this one only, QD is equal to 200 minus 2P. If price is equal to 1 rupees, how much quantity demand? The quantity demand is 198. And if the price of the commodity is 2, the quantity demand is 196. Here, here it is called, see, if the price of the commodity is increased by 1 rupee, the quantity demand is going to decrease by 2 units. 2 units. 2 units. Two units. So that's why, see, there is an inverse. Sai Kiran, please unmute your audio. Yeah, thank you. Yeah, see. So that's why the change in quantity demand divided by change in price. Nothing but if the price of the commodity changes by 1 rupee, the quantity demand is going to change by 2 units. That's why the minus 2. So that's why I take into account that is a minus 2. As it is, I put into here. This symbol is for into. What is the p value here? They mentioned p value is 10. They divided by QD. What is the QD here? They have mentioned the equation, but they didn't tell that how much QD. So we need to find out the QD. That's why, see, I put it here. QD is equal 200 minus 2P plus 0.5Y plus 0.2 PZ. Then here P value, Y value, Z value. So they have mentioned the P value, Y value, Z value. Simple, we can substitute this P, Y, PZ values in the model. Then see 200 minus 2P, then P is equal 10 into 10, 0.5 into Y. So Y is equal to 200 plus 0.2 into PZ is equal to how much? 100. So as it is, I can put it 200 minus 2 into 10 minus 20 plus plus into plus plus 0.5 into 200 100 plus 0.2 into 100 20. So if you add these positive values 200 plus 300 200 plus 200 300 300 plus 20 320 320 minus this 20 300 320 minus 20, the QD is equal to 300. So that this QD is equal to 300. So I put it here 300. Simple, I substitute these values. See, the delta QD by delta P is nothing but this minus 2P. Simple, you can remember. It means that the price of the commodity change by 1 rupee, the quantity demand is going to change by 2 units. Nothing but if the price is going to increase, the quantity demand going to decrease by 2 units. That's why minus 2 into P is equal to 10, QD is equal to 300. See here is equal minus as it is minus 2, you can take into account same into. Then if you cancel 10 by 300, you will going to get 0.0333. Then if you multiply 2 into 0.0333, you will going to get the 0.0666. That is the price elasticity is equal to 0.06. The price elasticity is 0.066, which is less than unity, which is less than unity. Nothing but unity is nothing but 1. Is it clear now? Hello, dear students. Is it clear now? Hello?
Yes, sir.
Yeah.
Yes, sir.
Then we'll come to know that how we can estimate that elasticity of income. So elasticity of price is over. Then we can come to know elasticity of income. See here. The same. We need to find out elasticity of y. So what is the formula? Elasticity of y is equal delta qd by delta y into y by qd. So what is the delta qd by delta y? How much value is there? Nothing but if you change in, if your income is changes by 1 rupee, how much the demand is going to increase? See here, if your income is going to by 1 rupee to 0.5, nothing but half of the, nothing but 50 nothing but we can say that 0.5 units going to increase by demands. Nothing but when your income is increased by 1 rupee, the counter demand is going to increase by 0.5 units. 0.5 units. So how much is there? Nothing but the ratio of QD by Y 0.5 into 0. Y is equal to how much? They mentioned also here y is equal 200 divided by QD is equal to how much? Already we estimated 300. Okay. Then as it is, we can take 0.5 into 200 by 300. How much you are going to get? So I am using calculator here. See, 200 divided by 300. How much? 0.666. 0.666. You can take 4 decimals. Then if you multiply with 0.5 into 0.666, how much you are going to get? 0.666 into 0.5. How much? 0.3333. 0.33 is the answer. This is the estimation of elasticity of income. Okay. Then we need to estimate that elasticity of PZ. Elasticity of PZ. See here, elasticity of PZ is nothing but change in quantity demand divided by change in PZ into PZ by QD. So change in quantity demand by change in PZ is how much is there? The coefficient value 0.2. 0.2 into the PZ is how much? They mentioned 100 divided by QD 300. Then same 0.2 into 100 by 300. How much? 100 by 300. 0.333. So 0.333. Then you can multiply 0.2 into 0.3333. 0.0666. Zero point zero six six. 0.066. See, this is how we can estimate the coefficient elasticity of PZ. Is it clear now how we can estimate that elasticity in the simple in the basic statistics? Hello, dear students. Hello, are you there? Redmi mobile. Sai Kiran, Chilasaga, Maheshwari, Krishna, Saraswati, Maunika, Kamatam, Shailaja, Srikant. Hello, is it clear? అర్థమైందా? Is it clear now? Okay, thank you. Then we'll come to know that how
Yes,
we can
sir.
we'll come to know that how we can estimate elasticities in the multiple regression. So in order to understand basic thing only, I have explained here how we can estimate the elasticity. Then in regression analysis, how we can estimate the elasticities. So the estimation of velocities with the help of the regression coefficients. For example, in the previous class, we have discussed about that. What is how we can estimate the parameters on the base of these values? There's the demand, price, and income. So we have taken the 10 observations of the particular demand variable value and price variable value and income variables values. So we got the parameters value on the base of this equation. This is a yi is equal to beta 0 plus beta 1 x1 I, beta 2 x2 I, epsilon. So here this is a multiple regression. So on the base of this deviation method or direct method, direct deviation method. So we have calculated the beta 0, beta 1, beta 2. So manually we will go with this, we will calculate the values by using these formulas. So if you are not interested to do manually, you can estimate the parameters by using the different software, Excel, SPSS, EU, Stata, or other variables, other software, sorry, other softwares. So simple, I've used that Excel software only to estimate the parameters by using this data: demand, price, income, these 10 observations. So the summary output is like this. Already I showed you in the last class also. So here, the coefficient interest, that is the beta 0 is equal to this one, 311.6918, and the variable x1, that is the price value, minus 7.18824, and the x2 variable, that is the income variable value, Yeah, x2 variable, that is income value, 0.01429. There is a coefficients value. These are the, so these are the standard error values, and this is the t statistics value. These are the p values. So here, basically, how we can estimate the elasticities here? Simple, on the base of these values and the average values of x and y, x average value, y average value, and x2 average value. Simple here, see how to estimate the elasticities. For example, this is the previous model, the beta 0, beta 1 x1, beta 2 x2 epsilon. So here this equation we need to write the beta 0 is equal to how much? Already explained, 311.88. So 311.69 something. So don't confuse that, no problem. 0.78, and beta 1 is equal to 7.18 plus 0.014 x2 value and epsilon. So the average of y value 80, x1 value 6, and x2 value is 800. So average value is nothing but sum of y value by number of observations. Sum of x1 is nothing, average of x1 is nothing but sum of x1 by number of variables, and x2 average value is nothing but sum of x2 by number of variables. Nothing but here we got the value. See here, the average value of y is 80, and average of price is 6, and here income of the average value is x2 is equal to 800. So that's why I put it here. Average of y is 80, x1 is 6, x2 is equal to 800. So in, see here, y is equal to dependent variable, x1 is variable here, there is a price, x2 variable is the income, y is the demand, epsilon is the error term. Then see, first we need to write this one, and see we need to estimate the price elasticity of demand. Price elasticity of demand, nothing but price elasticity demand with respect to, or we can write elasticity of demand with respect to price only. Then the formula of price elasticity is simple in the regression analysis. Simple, you can remember. Elasticity of price is equal to beta 1 cap. This is beta 1 cap into x1 bar. You can write bar also, no problem. If you put here bar symbol, and you can write it under above x1 bar. Then y bar, or simple you can write it here. Elasticity of price is equal to beta 1 cap into x1 bar by y bar. Nothing but x1 bar is nothing but average of x1 value by average of y value. So here beta 1 value nothing but estimated beta 1 value. Whatever the estimation is there, the beta 1 value, this just minus 7.18. That is the value. So in previous class, we have taken that delta QD by delta, here delta y by delta x1. So here, that's why we are taken before that minus 2 like that. So here minus 7.18. So here we can write it beta 1 cap. Beta 1 cap nothing but estimated coefficient of x1. So here beta 1 is nothing but how much? 7.18. 7.18. So 7.18. See, we can substitute these values beta 1 and x1 and y values in the equation one model. See, elasticity of price is equal to beta 1 is how much? Minus 7.18 into x1 is the average of x1 is how much? Here 6 divided by y value 80. So 0.78 into 6 by 80 is equal to how much? When you cancel 6 by 80, you are going to get 0.075. Then you can multiply with this value with 0.075. Then only you will get minus 0. 0.538 is the price elasticity of demand. Price elasticity of demand for a particular data set. Is it clear now? Hello? Hello, dear students. Is it clear? అర్థమైందా లేకపోతే ఇంకోసారి చెప్పనా?
Clear.
Sir.
Yeah. Because such kind of questions will ask in the UGC net exam or set exam or other DL, JL exams also, they will ask this type of questions. Then see, income elasticity of demand. How we can estimate the income elasticity of demand? That is a EY. So here, see, I'm going to estimate. See, income elasticity is how much? The elasticity is equal to how much? Here, the coefficient of beta 2 is equal to how much? 0.014. So here simple, you can write it here 0.014 into what is the y bar average of x2? Average of x2 is equal to how much? Average of x2
0.2
800 divide by y bar, or average of y value is how much? 80. Then see 0.014 into something deep sound is coming. Please unmute yourself. Cycling, please. Yeah, 800 by 80 is how much? 800 by 80, 10. Okay, then 10. Then multiply 10 into 0.014. How much? 0.14. 0.14 is the answer. Okay, the elasticity of demand is equal to 0.14. 0.14. Okay, is it clear now? Or we can estimate the elasticities in the regression analysis.
Sir.
Simple, you can remember. Say elasticity of price is equal to, or elasticity of demand is equal to. So here beta 1. Think about beta, coefficient of beta 1 is nothing but minus 7.18. So you will take 7.18 into x bar value, x1 bar. X1 value is equal to how much? Average, nothing, x1 bar is nothing but average of x1 value. Average of x1 value is 6 divided by average of y value. Average of y value is equal to 80. 6 by 80. So see, as it is, you can take 7.18 into 6 by 80. So you are going to get 0.075. So then you can multiply with 7.18 to 0.075. Then you will get 0.583. Nothing, negative value. Okay, because there is a negative value there, so you can, there is a negative. So here also same 0.014 into average of x2 is equal to how much? 800 divided by average of y value, 800 by 80. So you will get 10 value. Then 0.014 into 10. Then you will get 0.14. This is the how we can estimate the elasticities. Then see, the estimation of beta 1, beta 2 indicates that percentage change in y due to change in due to percentage change in x. So simple here, when you are estimating the elasticities, simple we can code this elasticities. Nothing but if the price, if the see here, it means that the elasticity price is equal to 0 minus 0.538. It means that percentage change in price 1 to, for example, if the percentage change in price, or if 1% change in price, the demand, it leads to changes in 0.53 in demand. Nothing but when 0.1% change in price, it leads to decrease by 0.53%, 538%. It means simple here. Here, if 1% increase in price, it leads to decrease by 0.5 0.538%. So that is the meaning of elasticities. That is the meaning of elasticities. Okay. So when it comes to that, this one, see here 0.14. What it means that if 1% change in consumer's income, it leads to increase by 0.14%. Nothing but there is a positive relation. Here there is a negative relation. So as per law of demand, there is a negative relationship exists between the price of the commodity and demand of the quantity. So whereas income and demand, so there is a positive relationship. For example, see here if 1% change in, if 1% change in 1% increase in income, it leads to increase the demand by 0.1%, 0.14 percentage. So there is a positive relationships. Okay, then we will come to know that that's why the estimation of beta 1 beta 2 indicates the percentage change in y due to change in percentage change in x1 and